All right, guys, so today we are starting chapter 6. All right. All right, guys, so today we're starting chapter 6. Chapter 6 is going to be talking about relationships inside of triangles, dealing with angles and side lengths. Well, we'll see. Now, when we look at this here, guys, so the first theorem we have is the perpendicular bisector theorem. In a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if we have a point C that lies on the perpendicular bisector of line AB, then we can say that CA and BC are congruent. So point C lies on the perpendicular bisector of AB, then we can say that AC and CB are congruent. Thank you. Questions on this so far? So, here point S does lie on the perpendicular bisector of line RP, and they tell us that line SP is 6.8. So RS is
Guys, let's not get too excited. I don't know what's coming up.
questions on this here. CD, because point D does lie on the perpendicular bisector, so CD is 27. Questions on this here? Okay, so we have the converse of the perpendicular bisector. So guys, let's focus in. If in a plane, if a point is equidistant from the endpoint of a segment, then it lies on the perpendicular bisector. So if point D is equidistant from the 2 points AB, then it must lie on the perpendicular bisector. So here we can say that EH is congruent to HG. So it means point H lies on the perpendicular bisector. So therefore, EF and... So what is EF? So EG... So we can add it together, yes. So 9.5 plus 9.5. Any questions on this here? Questions on anything we've done so far? So, we see that the two sides here are congruent. So both of those lengths would be 5, which means the whole length PR would be 10. Any questions on any of this here? So, we want to find the length of AD. Now, from the setup of this triangle, we know that these two lengths are congruent. So to find the length of AD, we need to find the value of x. So we can say that 3x plus 14. Now we just need to solve for the value of x. So the first thing we can do is minus 3x from both sides, which tells us that 2x is equal to, and then divide both sides by 2, telling us x is equal to. Now we just need to plug it back in. Which equation would we plug it back into? So 5x would be 5 times, which is, so that tells us that AD is what if I plugged it into 3x plus 14? 3 times 7 plus because we said those two links are congruent, they're the same. So it really didn't matter which one we plugged it in, because they should give us the same value, as long as we have the correct value for x. Questions on this here? This time we want to find GH. Well, again, these two links are going to be the, so we can say 2x is equal to 3x minus 8. Minus 3x from both sides, which tells us that negative x is equal to negative 8. So x is almost.
You have to divide it.
Well, if negative x equals negative 8, then positive x must equal positive 8. If I change the sign of one side, I have to change the side of the other. Now we do need to plug it back in, so I could plug it back into 2x, which is 2 times 8, which is, because we could have done 2 times 8, or 3 times 8 minus 8, which would be 24. Minus 8, which is still 16. So the length of GH is 16. Questions on any of this here? Okay. We'll look at one more of these and then move on to the next part. ZX is perpendicular, is the perpendicular bisector of WY. YZ is 13.75. Find WZ. Yeah. Any questions on this here? Do we feel comfortable with this? All right. We'll move on to the next part. Our next theorem, angle bisector theorem. If a point on a line, if a point on the bisector of an angle, let's start that one more time. If a point lies on the bisector of an angle, then it is equidistant from the two sides of the angle. So, since point D lies on the angle bisector, it means that BD and CD are going to be congruent. So, BD is the angle bisector of ABCD. So, it means that these two lengths are going to be the same. So, DC is 6.9, so DA. And that's it. Now, one of the other things is that when we have these angles, the angles for A and C of this here are going to be 90 degrees. Otherwise, it doesn't work as well. Because whatever the length or the length from the line that we take has to be at the same angle. So I can't take one at 90 and the other at 30. They have to be at the same angle. Does that make sense? So We want to find JM. Well, these two lengths are so we can set 4x equal to and the first thing we can do is minus 2x. 4x minus 2x is equals 12. And then we can divide by 2, so x is, which one do we want to plug it back into? 4x. So we'd have 4x, which would be 4 times 6, which is the length of questions on this here? I don't think that's the right note sheet. Thank you.
Yes, I was.
You're welcome. Any questions on this here? If we feel comfortable with these, we'll move on. Converse of the angle bisector theorem. So if we have a point that lies, if a point in the interior of an angle is, if a point is in the interior of an angle, so point D, and is equidistant from the two sides, then it lies on the angle bisector, which means these two angles would be congruent. Yes. So we have a point J, which is in the interior of the angle. We see that JG and JH are congruent. So it means the measure of angle GFJ, 42. Let's see what it asks for, GFJ. Yes, so this here is, it didn't ask for this, but what would the measure of angle GFH be? Yep.
Because 7 plus 7. Wait, no, that's not 14, is it?
7 and 7 is 14.
Okay. I was like thinking in my head, I was like typing. I was like, wait, huh?
7 times 7 is 49.
Okay, yes.
So this here would be what? Because ABD is 56 degrees, but it asks for ABC, the whole angle, which would be 112 degrees. Questions on this here? Are we ready for the next one? Find the measure of ABC if AD is 3.2, CD is 3.2, and DBC is 39 degrees. Well, what do we know about angle DBA? So the measure of angle ABC is almost 78. You're good? Questions on this here?